Okay, let's have a look at the fourth case, or fourth type of question we deal with in projectiles, and that's where we launch an object below the horizontal. So to do that, we're going to do a problem for this one. So let's say we say a ball is launched from a cliff at a velocity of 40 meters per second and an angle of 20 degrees below the horizontal. And we're asked to find three things. First of all, the time in flight, the range of the object, so the horizontal distance from the cliff, and the final velocity of the object on impact. So the first thing we do is draw our diagram. We've got our 150 meter cliff here. We're launching the object below the horizontal and it's going to land at some distance away from the cliff. Now by convention, we'll make our upward direction positive, and that's why our distance vertically, our displacement vertically, is minus 150 meters. So we're going to blow this up to see what happens at the start of this launch. So the object is being launched 20 degrees below. We need to first of all find the component of velocity or initial velocity in the x direction and in the y direction. So the same as we've done for the first three cases, we're going to use our trigonometric rules, and our initial velocity in the x direction will be equal to the initial velocity times the cosine of the angle. And putting the numbers into this, we find that in the x direction, our initial velocity is 37.6 meters. Similarly, we're going to use the sine relationship for our component in the y direction. So our velocity in the y direction will be 13.7 meters per second. Now, because this is traveling down, we need to put that negative sign in, because by convention we're moving, or positive direction is up, therefore initially we've got some component in the y direction that's moving down, therefore it's negative. So if we put all of our information into our table, we find that in the x direction we know the initial and final velocities. We know those are the same because we've got an acceleration in the x direction of 0 meters per second. What we don't know is the time or this displacement or range. In the y direction we know the initial velocity but not the final velocity, because this object is being acted upon in the y direction. So there's an acceleration here of minus 9.8 meters per second squared, and our displacement in the y direction will be minus 150 meters. So looking at the first part, we want to find out the time in flight. We know these three. We want to find t, so our equation that we're going to use is s equals ut plus a half at squared. So if we use these values, we have an algebraic or quadratic expression that's 4.9t squared plus 13.7t minus 150 is equal to 0. And solving that using our quadratic formula, we have two values for t. One is 4.31 positive and the other is minus 7.11. Therefore, we can't get a negative time, so our value must be 4.31 seconds. So the time in flight is 4.31 seconds. The second part of the question asks us for the range. So we've got our initial velocity, we've now got our time in flight. We use s equals ut plus a half at squared in the horizontal direction now. We know that we don't have any acceleration on this object, so it's going to be equal to, or our range is going to be equal to ut. So 37.6 times 4.31 gives us a range of 162 meters. Part 3, we're trying to find the final velocity, and there are two components to that. The first part is that we need a scalar value, and we also need an angle here for this impact as well. So the information that we have, we've got a velocity in the x direction, we don't have a final velocity in the y direction, but we have an initial velocity, a time in flight, and an acceleration, and we can use v equals u plus at to get this final velocity, and we calculate it as minus 55.9 meters per second, negative value because we're traveling down. So putting these together, we can now use Pythagoras' theorem, and we can also use a trigonometric ratio, our tan, to give us our final angle. So if we look at this, our final velocity squared must equal our final x component squared and our final y component squared. Putting those numbers in, we get a value, once we do the square root, of 67.4 meters per second. If we look at the angle, we use the tan of both of these two, our x and y velocities, inverse tan here for our angle, and we find that it's a minus 56.1 degrees. So what does this minus value mean? Well, our final velocity, if we put this into the same expression that we had to begin with, will be 67.4 meters per second at an angle of 56.1 degrees below the horizontal. And that's how we approach a problem like this.